Hi, good afternoon. These notes are on constant proportionality part 2. We have Fiona the frog and Wally the whale joining us today. Page 84 of your notebook is where these notes should be. So let's go ahead and get started, and if they want to say anything, they'll just kind of chime on in. All right, so let's take a look at the notes that I've already filled in. At the top is a sentence we've already done in our last set of notes. So the constant proportionality is the constant value of a ratio of two proportional quantities, x and y. It's a number that's multiplied by k. Actually, it's multiplied by x. Okay. How to determine if a relationship is proportional from a graph. So this is, again, remembering from our last set of notes. The first thing about a graph is it has to be a straight line. It has to go through the origin if it's going to be a constant of proportionality. And the origin is 0, 0. All right, how to determine if a relationship is proportional from a table. So last time when we were looking at tables, we did y divided by x. And as long as it was the same unit rate every time, we knew that it was a constant proportionality. Again, if the constant is the same, then the table is proportional. And then the third way we're able to tell if something was proportional was from an equation. And the equation has to look in this form, y equals kx, where k is your constant of proportionality, your COP. The x value is being multiplied by that COP, which is your k value. So that was just a recap of what we learned in our last set of notes. And then the last question, how does the constant proportionality compare to the unit rate? They are the same as each other. The constant proportionality is a unit rate. These are just synonyms for one another. So then what we're going to do is we're going to practice using our information that we've learned and try on some more problems. So our first example, Joe can do 10 multiplication problems in 5 seconds. So the unit rate, we're going to do problems divided by seconds because it's our dependent divided by our independent. Our dependent is our problems, so 10, and then divided by 5, and that gives me 2 problems a second. So 2 problems every 1 second. At this rate, how long should it take Joe to do 2 multiplication problems? It should take him 1 second. What if he was doing 18 problems? It would only take him 9 seconds. Then down here, part C, fill in the table and plot the points on the graph below. So they've given us a certain values in the X column of the seconds that they want us to use. And then we just have to tell them how many problems he'd be able to do in that amount of time. So at 0 seconds, he's going to do 0 problems. At 1 second, he'll do 2. At 2 seconds, he'll do 4. At 3 seconds, he'll do 6, and then 8, and then 10. We're going to take these values, and we're going to plot them on the coordinate plane. So 1 or 0, 0 is our first point. 1, 2 is our second point, so 1, 2. And if you want to write your ordered pairs here, just to practice, you can. Sometimes I think that helps students to see the relationship of a table to a coordinate plane. Again, this is not necessary, but if you'd like to see the relationship, you can. All right, so those are all the ordered pairs that we got from the table, and then we're just going to plot them. At 2 seconds, we are at 4 problems. At 3 seconds, we're at 6 problems. At 4 seconds, we're at 8 problems, and at 5 seconds, we're at 10 problems. And then we're going to graph the function. So then the last step, and it wasn't in here, is we're going to write the equation. So we have our table. We have our graph, and now we have our equation. Y is equal to, our constant of proportionality is 2. That's our COP. And then you just put X. So from the table, we were able to determine that it was 2 problems every second. So that's where we got the 2 from. So let's check all 3 things. Do they fit in the rules for graphs, tables, and equations? Well, let's look at the graph because that's the easiest to see. Is it a straight line? Yes. Does it go through the origin? Yes. So this is a constant proportionality. Here, 0 divided by 0 is 0. 2 divided by 1 is 2, 4 divided by 2 is 2, 6 divided by 3 is 2, 8 divided by 4 is 2, 10 divided by 5 is 2. So these give me the same rate, minus a 0, 0, which that's just to show you it goes through the origin. So I still get the same constant proportionality from the table. And then from the equation, is it in the correct constant proportionality form? Y equals kx. Yes, it is. So all three things let us know that this is a proportional relationship. All right, let's go on the inside. Oh, Wally just wanted to let you know this seems really, really cool, and he's glad that we're doing all these notes and practicing this again. Thanks, Wally. All right, so example 2, the graph below represents the total number of cups of coffee and the total amount of people, or no, I'm sorry, the total amount of pounds of sugar to make the coffee. So right here, is the relationship proportional? Well, if we're looking at just this graph, I'm going to say yes, because the reason, it's a straight line and it goes through the origin. So right here, straight line, and goes through origin. And I'm just going to write 0, 0 just to save space. All right, so what is the constant proportionality? So what we can do is use one of the points given, so 4, 20. So 4, 20. All right, this is my x value. This is my y value. We know to find the COP. So to find your k value, you have to do y divided by x. So y is 20. X is 4. Oops. X is 4. And 20 divided by 4 is 5. So our k value, our COP, is 5. So now we're going to use this k value that we just found, and we're going to write the equation to represent it. So y is equal to 5x. And then we're going to use that information, and we're going to fill in the table to the left. All right, so we're going to use the graph. So at 0, 0, at 4, 20, 8 and 40, 12 and 60, and then 20 and 100. Find the number of cups of coffee you can make with 10 pounds of sugar. So remember, X is your pounds of sugar, and then this is your cups of coffee. So if at 20 pounds we can make 100 cups of sugar, 100 cups of coffee, then if we cut this in half, then we can make 10 pounds. So we could set up a proportion if we want. So 20 cups of sugar, or 20 pounds of sugar makes 100 cups of coffee, is the same as 10 pounds of sugar is, well, if that's half, then that has to be half, so 50. So that was using the table. All right, down here we're just going to practice. So all they're saying is determine if the following has a constant proportionality. If it does, what is the constant proportionality or the k value? So let's look at this table. 0, 0, that has to happen. Okay, they don't have to show it, but it does have to be true. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. So this would be yes. And the k value would be 3. I'm going to move my paper because it's hard to write. 1 second. Okay, here we go. Thank you. Okay. And then here, 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3 is, whoa. So right here and right here, this gives me 2, this gives me 2, but this gives me like 2 point something. 8 divided by 3 gives me 2.66. And then this gives me 4. So this would be no, because the constant proportionality is not the same. All right, you're going to try number 3 on your own. All right, down here we got 3 graphs. So it has to be a straight line and it has to go through the origin. This one's straight line and through the origin, so yes. And then this constant proportionality, well, I'm going to find a point. So 1, 2. So I'm going to do 2 over 1 because it's my y value over my x value. So it's 2 over 1, which is just 2. All right, this one does not go through the origin, so we're going to say that this is not a constant proportionality. All right, go ahead and try number 6 on your own. And then you're going to go ahead and complete number 7 and 8 on the right side. I am going to pause the video so that you guys can take a few minutes to try it on your own. And then when you're ready, unpause the video. All right, here are the answers. So the number 3 and number 6, I found the K value was 5 for each of those. So that means that they're all the same, which tells us that it's proportional. This graph is not a constant proportionality. It's a baseball being thrown into the air. The reason why, it does go through the origin, but it's not straight. So that's the reason why this one is no to constant proportionality. All right, over here is talking about the number of chocolates consumed by people, and we've done this problem before. So here are all my values from the graph, and I put it in the table, and each time it was 2 as my K value. So my constant proportionality was 2. My equation y equals 2x. The number of people who, the number of chocolates eaten by 20 people. So I use my equation y equals 20x. X is my number of people, so y equals 20 times 20, and 20 times 20 is 40 people. And then what does the coordinate 918 mean in the context of the problem? 9 people ate 18 chocolates. And then down here at the bottom, it's comparing saltwater taffy at 2 different stores. So you have option 1, 3 pounds for $4.50. Option 2, $1.75 per pound. So what I did was for the first one, I found the unit rate was $1.50, and then I added to get $3, and then I got back to the $4.50 that they told me. And then from here, I just used the 1.75, added 1.75, and got $3.50, added 1.75 and got $5.25. Then I wrote the unit rate, but I also wrote it into the equation, y equals $1.50x, and this is y equals $1.75x. I then graphed them, and that was able to show me 2 different things, both that were able to tell me that option 1 was the better deal. And the reason why, well, look at option 1, it's the flatter one, so it's growing less, so it's cheaper. And then you could also look at the K values, that this is smaller, so therefore it's the cheaper, so it's the better deal. All right, well, if you guys have any questions or comments, just put them at the bottom of the video, and I hope you guys have a great afternoon.